This is Algebra Lesson 9-1, Adding and Subtracting Polynomials. There's a great deal of vocabulary with this lesson, and the vocabulary is very critical that you understand. Therefore, I'll be giving examples next to each vocabulary word. I suggest you write the examples down as well as the definition of vocabulary words. A monomial is an expression that is a number, a variable, or a product of a number or one or more variables. For example, this would be considered a monomial. 3, 2x is a monomial, 4x squared y to the fourth z is a monomial. There are no plus or minus signs within a monomial. It is one term, one expression. It can have multiplication symbols like crazy, which means numbers multiplied by variables, but it cannot have any addition or subtraction signs. The degree of a monomial is the sum of the exponents of its variables. For a non-zero constant, the degree is 0. In our example above, for 3, the degree of 3 is 0. For 2x, the degree of 2x is 1 because the variable x is taken to the first power. For 4x squared y to the fourth z, the degree of that term is the 2 plus the 4 plus the 1 on the variables, 2 from the x, 4 from the y, 1 from the z, so the degree of this one is 7. So a constant term, a non-zero constant term, which means a number with no variables, it has a degree of 0 because it's the sum of the exponents of its variables. A polynomial is a monomial or a sum of monomials, which means more than one monomial. For example, 3x plus 6, that's called a polynomial. It's a special type of polynomial, which we'll talk about in a minute. I could also have 6x to the fifth plus 5x squared y minus 2xy plus 7. That is also a polynomial. It's a polynomial that has 4 terms. Each term is separated by a plus or minus sign. So there's a term, here's a term, here's a term, and here's a term. A binomial is a polynomial with exactly 2 terms. So 3x plus 6, not only is it a polynomial, but if you wanted to be more specific, it is a binomial. It's kind of like saying a German Shepherd. Not only is it a dog, it is a German Shepherd. German Shepherd is a more descriptive type of dog than just saying it's a dog. Other types of monomials, 4x squared minus 6, okay. 2x to the fifth, y to the seventh, z plus 3x to the fourth, y to the sixth. That would all of those are examples of binomials, 2 terms. Prefix bi means 2. Trinomial is a polynomial with exactly 3 terms. The prefix tri means 3, so it has 3 terms. 3x squared plus 6x plus 9 would be an example of a trinomial. Has 3 terms. Again, terms are separated by plus or minus signs. So 3x squared is 1 term, 6x is a second term, 9 is your third term, making it a trinomial. Standard form of a polynomial. A polynomial is written so that the degree of its monomials decreases from left to right. As you can clearly see, I've already written most of mine in standard form because I'm used to writing them that way. Standard form of a polynomial would be something like 3x to the third plus 2x squared plus 5x minus 6. Because we had our x, okay, your x term if you notice, third power, second power, first power, no power. Okay, so decreased from left to right. If you have more than one variable, you normally go with the variable that is first in the alphabet. So x would decrease before y would decrease. A coefficient. A coefficient is the numerical factor of the term. So let's just take the following. 3x to the third minus 6x squared plus 5x minus 9. The coefficient of the first term of this example is 3. My coefficient here is 3. The coefficient of negative 6x squared is negative 6 because the sign goes with the number. It's not positive 6, it is negative 6. The coefficient part of 5x is 5, and the coefficient part of negative 9 is not negative 9. It's negative 9 is also the constant term because there is no variable. Okay? A coefficient can be a constant, and a constant can be a coefficient. Like terms, terms whose variable factors are exactly the same variable raised to the same power. Okay, for example, like terms would be 3x squared y is a like term to 7x squared y. Same variable, x squared, and y. Those would be like terms. They would not be like terms to 4xy squared. Those are not like terms. Because here we have an x raised to the first power and a y raised to the second power, where here we had an x raised to the second power and a y raised to the first power. In order to be like terms, they have to have the same variables raised to the same power. A leading term. A leading term is the term with the highest degree. Right? Normally, when you write it in standard form, that is the first term that you write. So 7x to the 4th y squared minus 2x to the 3rd y to the 4th plus 6x squared y. On those three examples, my leading term would actually be my middle term here. Okay? My middle term would be the leading term because the degree of the term is the number of the variables added together. So the degree of 7x to the 4th y squared is 6. The degree of 2x cubed y to the 4th is 7. And the degree of 6x squared y is 3. So the highest degree is my middle term. So my leading term here is negative 2x to the 3rd y to the 4th. That would be my leading term. The leading coefficient is the number, the coefficient of the leading term. So in this previous example, my leading coefficient is negative 2. Sign goes with number. The degree of the polynomial is the highest degree of any one of its terms. For example, if I have 7x to the 3rd y squared plus 3x squared y minus 6x y squared minus 7. That's my polynomial. It happens to be a polynomial of 4 terms. Okay. This particular polynomial has the degree of the polynomial is the highest degree of any of its terms. This has a degree of 6. This has a degree of 3. This has a degree of 3. This has a degree of 0. So the degree of the polynomial is 6. It's the highest degree of any of its terms, whether it's in standard form or not. Lots of vocabulary, very important. I will refer to it all of the time, so it's a good idea to pay attention to it and make sure you understand it. Okay. Once you can find the degree of something, okay, you're going to be pretty decent. So let's look at the degree of each monomial here. Number 1, it's a constant. It's 18. Remember, all constants have a degree of 0. So the degree of this term is 0. If we look at number 2, we have an x to the 1st, y to the 3rd. Don't forget the variables that are not raised to a power other than 1. The power is 1. So this has a degree of 4. Number 3 has a degree of 2 plus 4, which is 6 plus 1. So this is a degree of 7. Problem number 4 has a degree of 1, because it's c to the 1st power. And problem number 5 has a degree of 8, because you add the 1 from the f, the 5 from the g, and the 2 from the h. 5 plus 2 is 7, plus 1 is 8. After you simplify a polynomial by combining like terms, you can name the polynomial based upon the degree or on the number of the monomials it contains, or both. For example, you'll see here we have a polynomial 7x plus 4. It has a degree of 1 because the highest term is 1. We call anything that's taken to the 1st degree a linear polynomial because it will make a line if you were to graph it. So it's called a linear polynomial. This particular one has 2 terms, so we can name it a binomial. So if we wanted to name it using its degree and the number of terms, okay, this is a linear binomial. 3x squared plus 4x minus 9 has a degree of 2 because my leading coefficient has a degree of 2. That's the highest coefficient of the entire thing. Anything to the second degree is called a quadratic. Anything that just has a degree of 2 is called a quadratic polynomial. In this particular case, it has 1, 2, 3 terms, so we call it a trinomial. So this is a quadratic trinomial. 4x cubed, again, has a degree of 3. Anything to the third degree we call cubic. This happens to only have 1 term, so we would call this a cubic monomial. 9x to the fourth plus 36 is a 4th degree, because it has the power of 4 on the x. Sometimes people will call that quartic. 4th degree is the same thing, it's just as easier to remember 4th degree. And it has 2 terms, so it's called a binomial. If it has more than 3 terms, we just tend to call it a polynomial. Anything over 3 terms is called a polynomial. 6. If I have just a 6, it has a degree of nothing, 0. It's called constant, and it only has 1 term, so it's a monomial. It's a constant monomial. So now we're going to look at some examples of some polynomials. We're going to write them in standard form, which means in decreasing order of a variable, based upon its, and then we're going to name it based upon its degree and the number of terms it has. So if we look at this first one, negative 2 plus 7x. I have an x, which is going to be my highest degree, so I have to write it in descending order of the variable. The only variable is x, so this would be written as 7x minus 2. That's standard form. It has 2 terms, 2 prefixes by, so it's a binomial. The power or the degree is 1, so this is a linear binomial. Okay. We look at the second one here. I have a 3x to the 5th and a negative 2x to the 5th. These are considered to be like terms. We would combine them by just combining the coefficients, just the numbers. The variables get tacked on at the end. It's like saying 3 bananas and negative 2 bananas is actually only 1 banana. So we have 1x to the 5th or just x to the 5th. The next highest degree of anything with a variable is 7x here, and it's positive, so we'll put 7x. Last but not least, I have my number here, which is negative 2. So in standard form, this is written as x to the 5th plus 7x minus 2. It has 3 terms, therefore it is a trinomial. It is raised to the 5th power, so it's a 5th degree trinomial. That is naming it by its degree and number of terms. Last one, 6x squared plus 7 minus 9x to the 4th. Writing it in standard form means we have to start with the highest variable, which would be x to the 4th. There's a negative sign in front of it, so this is negative 9x to the 4th. There are no x to the 3rd terms, so then we would go plus 6x to the 2nd. There are no x to the 1st term, so then we would add the 7. So in standard form, this is negative 9x to the 4th plus 6x squared plus 7. It has 3 terms, so the trinomial. It is to the 4th degree, so we can call it a 4th degree trinomial. And that's how to put them in standard form and how to name them or classify them by the number of degrees and by the number of terms. Now, we can add polynomials by combining like terms, or you can add them vertically by lining up the like terms, combining the coefficients, or you can add them by horizontally by grouping the like terms. I have no preference which one you choose to do. I'll show you each one. In this first example here, we have 6x squared plus 3x plus 7 plus 2x squared minus 6x minus 4. The parentheses here are only to show you where the polynomial starts and ends. They don't mean multiplication. It's just to help you identify where does one polynomial start and end, and where does the next polynomial start and end. Literally, if you do them horizontally, you can ignore, for addition, you can ignore the parentheses. So I can just rewrite this as 6x squared plus 3x plus 7 plus 2x squared minus 6x minus 4. Because it's addition, we don't have to worry about adding the opposite or anything like that. Now we can just look at combining like terms. I have a 6x squared and a 2x squared, so that becomes 8x squared because 6 plus 2 is 8. I have a 3x and a negative 6x. So that becomes negative 3x. And I have a plus 7 and a minus 4, which is a plus 3. That's adding by just combining the like terms horizontally. Some people do really well with this, and I highly suggest that you box or circle or underline or maybe highlight in different colors so that you can keep your terms straight. And I have a tendency to find the highest degree of the term so that when I'm done writing it, it's already in standard form. If you combine things and it's not in standard form when you're finished, you need to make sure it's in standard form when you're finished. The second way you can add things is just add them vertically. Just line up your like terms. So if I took this first parenthesis, negative 4x to the third, plus 2x squared, plus 5x minus 6, and I'm going to add to that 7x to the third plus 5x plus 4, all I need to do is write it vertically, up and down, by putting the like terms underneath each other. So I have a 7x to the third plus 5x and plus 4. In this little hole here, I can just put a 0x squared because that's really what goes there. Draw my line and add like normal. Negative 4 plus 7 is 3x to the third. 2x squared plus 0x squared is 2x squared. 5x plus 5x, 5 plus 5 is 10, is 10x. Negative 6 plus 4 is negative 2. And I am done there. So you can either do it horizontally as in example 1, or vertically as in example 2. Let's look at example 3, a bigger one. Example 3 here. I have a tendency just to like to do them horizontally versus vertically because I can do them fairly quickly this way by just circling or boxing things. So that's probably how I'm going to demonstrate it more often than anything else. So I have, if I look at my problem, 2x to the fourth minus 5x squared plus 4x plus 5, and my next part, 5x to the fourth plus 7x to the third. So I look at it and go, okay, the highest term is x to the fourth. So I have a 2x to the fourth and a 5x to the fourth. That makes 7x to the fourth. Those are gone. If you choose to do this and you want to cross through them lightly so you can actually read what's underneath in case you make a mistake. If you obliterate it, I can never figure out what you're doing. On this one, I have a 5x squared, but I notice I also have a 7x to the third here in the second example, in the second part of the problem. X to the third comes before x squared, so I'm going to take care of that first. So I'm going to have plus 7x to the third. This is now gone. Now I can look at this and I say, ooh, I have a negative 5x squared and a negative 2x squared. That becomes negative 7x squared. Those are now gone. I have a plus 4x and a minus 2x, which makes it positive 2x. Those are now gone. And last but not least, the only thing I'm left with, here's Mr. plus 5 there. And I'm done. Okay, this happens to have 1, 2, 3, 4, 5 terms. So it's a 4th degree polynomial because it has 5 terms. You just name it as a polynomial. That's adding. Since subtracting is adding the opposite, when you subtract a polynomial, you change each of its terms to the opposite and then add it. Now you understand why the parentheses are so necessary. Not so necessary when adding, but here with subtracting, I need to know that this is the end of my first polynomial, and this is the beginning of my second polynomial. Otherwise, I'm not going to know where to change my sign and then add the rest. So the best way to do this is clearly to rewrite the problem. I'm going to keep, remember keep, change, change? This is keep, we're going to change this, we're going to change this. So I'm going to keep my entire first polynomial, 5x squared plus 3x minus 2. I'm going to change my subtraction to an addition sign, and I'm going to change all of the signs inside the parentheses, because you have to remember, you're basically running a negative through this parenthesis. So this becomes, because we keep, change this to an addition, add the opposite. The opposite of 2x squared, okay, is negative 2x squared. The opposite of positive 1 is negative 1. So now I have a plus minus here that I have to keep track of, but that's not so bad. So now I have 5x squared minus 2x squared, which makes it 3x squared. I have a 3x plus 3x. I have a negative 2 and a negative 1, which makes, negative 3. And there we have it. Simplified and in the proper form. Sometimes it's just as easy to do this. I'm going to keep this, change everything else. Negative a squared b squared. Change this to the opposite, plus 5ab to the third. Make this negative 3b. Change the sign of this, plus 2b to the fourth. There we go. I've changed all of the signs inside my second parenthesis here to the opposite. A squared b squared became negative. Negative 5ab to the third became positive 5ab to the third. Positive 3b became negative 3b. Negative 2b to the fourth became positive 2b to the fourth. So now I look at this and I go, okay, I've got 2a squared b squared minus a squared b squared. Remember, there'd be a negative 1 in there. So 2 minus 1 is 1. So I have an a squared b squared. These two went away. I have a 3ab to the third and a 5ab to the third. That makes 8ab to the third. Those two went away. I'm looking at this going, I have a 3b and a b to the fourth. Well, technically we went a squared, a to the first. We have no other thing, so I'm just going to go with this first, the negative 3b, and then the negative, and then I'm going to take care of the negative 4b to the fourth and the positive 2b to the fourth, which makes this negative 2b to the fourth. Technically, after this term and this term, the order doesn't matter. You could write this a squared b squared plus 8ab to the third minus 2b to the fourth, and then put the negative 3b at the end. It doesn't matter. The order of these is not critical. Okay? This order could be switched. Because of the fact that we ran out of a's. There are no a's in either one of these terms. And since we had a b to the third, you could go b to the fourth and then back to b, or b and b to the fourth. It really doesn't matter. So this is the answer to the subtraction of this problem. Let's do a couple more. Let's just do, we'll do one of the two of these. You can do the other one on your own. Let's see here. Let's do the third one. Okay, so I'm going to have 8x to the third plus 6x squared minus 3x plus 5. And I'm going to run this negative through as I'm working through the problem. So I have minus 5x to the third plus 3x squared minus 2x plus 4. Notice here that every one of the signs is the opposite. Okay, that's opposite. This is opposite. This sign here is opposite. And this sign here is opposite. So I added the opposite because there's my addition sign right there. So now I can just combine my terms. 8x to the third, negative 5x to the third becomes 3x to the third. These guys are gone. 6x squared, 3x squared is 9x squared. Because all we're doing is adding the coefficients. Negative 3x, negative 2x, sign goes with numbers, negative 5x. These two are gone. And last but not least, positive 5, positive 4 is positive 9. And there you have it. Do number 4 on your own. When you're done, resume the video. Essentially, adding and subtracting, combining like terms, and finding the degrees of your polynomials. All lesson 9.1.